Hello everyone, welcome back to my channel. So in this video we are going to see the differences between AM and FM. Okay, so that is amplitude modulation and frequency modulation techniques. Okay, if you are first time to my channel, please consider subscribing and encourage me to do more videos like this. So differences between AM and FM. Let me take the AM on one side and FM on other side to have the clear differences. So point by point we'll discuss now. So the first point here is the total power. PT is equal to PC into 1 plus mu square by 2 is the total power required in the case of AM. In the case of FM, PT is equal to PC. Okay, so normally FM means W by FM only will take, where R is not required. So antenna resistance, so AC square by 2. Okay, so this is the thing. This is the total power in the case of AM and FM. So if you compare, what is the difference here? AM requires more power to transmit than FM. Okay, so this is the difference, first difference. So it is FM requires less power or AM requires more power to transmit the signal than FM, right? Second, so another important here is in AM power varies with modulation index. And in the case of FM it does not vary. So in the case of FM, power is constant and is independent of modulation index beta. Okay, so this is the first difference with respect to power. Second, so the maximum efficiency possible in the case of AM is only 33% for modulation index is equal to 1. Okay, so this is the disadvantage of AM that we already have discussed in previous videos. Okay, so the maximum efficiency possible is only 33%. In the case of FM, the maximum efficiency possible is 100% if you take beta values is equal to 2.4, 5.5, 8.6, 11.8 and so on. Okay, so for these values of beta, carrier component vanishes and you will have only sidebands being transmitted. So when you are transmitting only sidebands, then efficiency is always 100%. As we have seen in the case of DSPSC, efficiency is 100%. In the case of SSB also, efficiency is 100%. When you are transmitting only sidebands without carrier, then so for these values of beta, carrier component depends on J0 of beta. So J0 of beta becomes 0. So when J0 of beta becomes 0, efficiency is going to be 100%. Okay, this is the second difference with respect to the maximum efficiency possible. Third difference is with respect to bandwidth. So what is the bandwidth in the case of AM? It is equal to 2 into FM. And what is the bandwidth in the case of FM? Bandwidth is 2 into beta plus 1 into FM. Okay, so if you elaborate this into two terms, 2 into beta into FM plus 2FM. So here it is only 2FM, but now here 2FM is added by something. So what can we write here? The difference, bandwidth required for FM is more when compared to AM. Yes or no? So bandwidth required for FM is more when compared to AM. Okay, so this is the third difference between AM and FM. Okay, so bandwidth here is independent of modulation index. Bandwidth here is independent of modulation index. because it does not depend on mu value. Mu is the modulation index in this case, that is AM. But now here it is depending on modulation index. So bandwidth depends on modulation index. Modulation index in the case of FM. Okay. So in FM, bandwidth depends on the modulation index. Okay. So these are the some of the differences. Let me take one more slide and I'll explain you some more differences. Okay. So the next difference here is the fourth difference. AM receiver is less complex. Okay, so AM receiver is less complex, and similarly the fourth point in this case FM is FM receiver is more complex. Okay, so in the upcoming videos we'll learn about this difference. Okay, so I'll explain you different types of AM receivers and FM receiver, and then we can compare that FM receiver is more complex, that is it requires more functionalities to be satisfied. Okay, so more components are required in the case of FM when compared to AM. Right, next in AM the effect of noise is more. The effect of noise is more. So in FM, effect of noise is less. Effect of noise is less. Okay, since in AM the message is stored in the form of amplitude of the carrier. Okay, so amplitude of the carrier, the message is stored in the amplitude of the carrier, and amplitude of any signal is easily affected by noise. Easily affected by noise. So noise always tries to decrease the amplitude only. That is the first thing it will attack. Okay, so noise decreases the amplitude of the signal. So the message is stored in the form of amplitude of the carrier, so it has more effect of noise. And here the message is stored in the form of frequency of the carrier. Okay, frequency of the carrier, so it will have less effect of noise. We cannot say there is no effect, but there will be effects, but the effect is less. Okay, so I will prove this when we discuss about noise analysis. Through some numericals also we can prove that. Okay, so we'll see that later. So the sixth point here is the important points, that is the important differences between AM and FM. So the carrier frequency used in AM is 550 kilohertz to 1650 kilohertz. Okay, so these are the standard values you have to remember. So the carrier frequency used in AM is 550 kilohertz to 1650 kilohertz. Okay, the intermediate frequency. Okay, so the intermediate frequency of the AM intermediate frequency is given by 455 kilohertz. The intermediate frequency used in AM is given by 455 kilohertz, and bandwidth allotted to each AM station, that is bandwidth of each AM signal, is 10 kilohertz. These are the standard values which you have to remember. Similarly, in the case of FM, FC, the carrier frequency used is 88 megahertz to 108 megahertz. Okay, and the intermediate frequency is going to be 10.7 megahertz. 10.7 megahertz, and bandwidth allotted to each FM station. Bandwidth allotted to each FM station is 200 kilohertz. 200 kilohertz. Okay, so these are the differences. These are some of the differences between AM and FM. Okay, in one more slide I'll explain you still some more differences. Okay, so the next difference is in AM. Okay, in AM we'll use ionospheric propagation. So ionospheric propagation is used in the case of AM, and line of sight propagation. Line of sight, in short we'll call it as LOS propagation. So line of sight propagation is used in the case of FM. Okay, so ionospheric propagation means we'll send signals and they will travel by reflections. Long distance travel is possible. Okay, so this propagation is called as ionospheric propagations. And line of sight propagation, so if there is a transmitter like this and a receiver like this, so they should see with each other. That is, the distance between transmitter and a receiver must be low in the case of line of sight propagation. Okay, so the distance between transmitter, they have to see with each other. That is why it is called as line of sight. Sight means they should see with each other. That means the difference or distance between transmitter and receiver is going to be less. Okay, so that is why due to long distance transmission due to ionospheric propagation, so area of coverage is more. Okay, so it can cover entire nation only. Okay, so throughout India we can transmit one AM signal like Akashvani. Okay, so Akashvani is the best example for AM signal. And area of coverage is less. Okay, so that is why an FM signal which is more popular in one area cannot be listened in another area. That is because of line of sight propagation. Due to line of sight propagation, the area of coverage is going to be less in the case of FM. Okay, so only within the permitted region only, that within the permitted city only, we are going to listen to that particular FM channel. So out of that city we cannot listen to that FM channel, but AM channel like Akashvani is going to be listened in any city within the nation. Okay, so that is the difference between AM and FM. And since area of coverage is more, frequency reusability is not possible. Frequency reusability is not possible in AM, and in FM frequency reusability is possible in AM. In FM. Frequency reusability is possible in FM. Since the area of coverage is more, the same frequency can be used in two different cities. Suppose if there is an FM channel of frequency 93.5 megahertz, okay, so it is used in one of the city, Mumbai. Okay, so same frequency 93.5 megahertz can be used in another city, say Bangalore. Okay, so you can use the same frequency in two different cities, because the signal which is transmitted in Mumbai cannot be interfered in Bangalore. So that is why frequency reusability is possible in the case of FM. That is why we will see the same FM channel which is located in different cities, like all the metropolitan and cosmopolitan cities will have the same FM channel with same brand name to be established in different cities. Okay, so this is possible because area of coverage is less, and area of coverage is less because it requires line of sight propagation. Okay, so these are the basic differences between AM and FM modulation schemes. Okay.